First we will define what is a null space. Null space of a matrix A, and then we will see how to find its basis and dimension. For example, we have a matrix A. This is M by N matrix with M rows, N columns, and it has entries like A11, A12 up to A1N. In the second row it has A21, A22, A2N, and in the last row it has AM1, AM2 AMN. So this is a M by N matrix, and we can see this matrix as a linear transformation from Rn to Rm, meaning we have a vector x1, x2 up to xn. This is a vector in Rn, and this is mapped to a vector a11 to a1n am1 up to amn matrix multiply with this vector x1 xn. When we multiply this matrix with this vector, we will get a vector in Rm. Let's see, when we multiply this matrix, we will multiply first row with this vector. We will get a11 x1 plus a12 x2 plus a1n xn, and in the second row we will get a21 x1 plus a22 x2 plus a2n xn, and at the last entry, when we multiply this last row with this vector, we will get am1 x1 plus am2 x2 plus plus amn xn. So we see this is a vector in Rm. So in short notation, we will write that a vector x in Rn is mapped to a times vector x, which is a vector in Rm. Then we can define null space of this matrix A. We will denote like null space of A. This is actually kernel of this map A, because we have seen this A can be realized as a linear transformation from Rn to Rm. So kernel of this map, which explicitly will consist of vectors in Rn that mapped to a zero vector under this map. So this is a definition for a null space of a matrix A. We can see that zero vector is in the null space of A because when we multiply matrix A with this zero vector, we'll get again a zero vector. So 0 is in the null space of A, and if a vector x and and vector y is in the null space of A, then alpha times vector x plus beta times vector y, it also belongs to null space of A, where alpha and beta are any real numbers. Yeah, what does this mean? This means that x is in the null space of A means that A multiply with vector x is 0, and similarly A multiply with vector y is a 0 vector. Then we multiply A with this alpha times x vector plus beta times vector y, and this is equal to alpha times A vector x plus beta times A vector y, and which is alpha times 0 because A times vector x is 0, and similarly beta multiply 0 and we get a 0 vector. So it means alpha times x plus beta times y is also in the null space of A, which shows that this null space is a vector subspace. It shows that null space of A is a vector subspace of Rn. Yeah, and now we will see how to find its basis and dimension of this null space. And for example, we are given a matrix A. Say we have a matrix A which consists of 1, minus 1, 0, 1, 0, 2, 1, minus 1, 1, 1, 1, and 0. It's a 3 times 4 matrix. It means null space of A would be a subspace of R4 because it has 4 columns, so it will be multiplied with a vector of length 4. Yeah. Then how we will find its basis and dimension? Then first row reduce the matrix A. We'll get a row reduce echelon form of this matrix. For this we will write first row as it is, second row also as it is, and third row we will actually subtract first row from the third row to get a 0 here. So it will be a 0 and 2, 1, and this will be minus 1. Yeah, and now we can see that this is third row is a multiple of the second row. So when we will subtract R2 from R3, we'll get a 0 in the R3 row. So first we write these entries 1, minus 1, 0, 1. This will be 2, 0, 2, 1, minus 1, and this will be a 0 because this is all these entries in the third row are same as in the second row. Yeah. So now we can write again. This is our matrix, and this matrix will be multiplied with the vector of length 4, x1, x2, x3, and x4. So when we multiply this one, we want to get a 0 vector. Yes. So what will be this one? When we multiply this one, we will get x1 minus x2 plus x4, and in the second row we'll get 2 times x2 plus x3 minus x4, and in the third row we'll get a 0 vector, and we want this should be is equal to the 0 vector, which means that first equation x1 minus x2 plus x4 is equal to 0, and the second equation 2x2 plus x3 minus x4 is equal to 0. So we want to explicitly solve these equations, and we want to check which variables are the free variables. And from equation 1 we can see x1 is equal to x2 plus x4, and from second equation we can write x3 is equal to minus 2 times x2 plus x4. So here it is plus x4, so here it will be minus x4. Okay, then we can write these equations in the vector form as follows, that x1, x2, x3, x4, we can write this vector as x2, because in the first position we have x1 is equal to x2, so here we will get 1 plus x4, and here we will write minus 1 because x1 is equal to x2 minus x4, and x2 is equal to x2, we will write 1 here and 0 here, and x3 is minus 2 times x2 and plus x4, so we will get minus 2 here and 1 here, and then x4 is equal to x4, so 1 here and 0 here. So it means that all those vectors which are in this kernel can be written as a linear combination of these two vectors, which means that null space of A is generated by these two vectors 1 1 minus 2 0 and minus 1 0 1 1, and dimension of the null space of A is equal to 2. This is how we will find basis and dimension for the null space of a matrix A.